Hello again. So today we are going to talk about absolute value function and the graph of absolute value function, which is that's the exciting part. Let's go back to the definition and the definition. If you guys remember, the definition of the absolute value is the given by this kind of algebraic form right here. There are two possibilities. One is that if x is positive, the absolute value of x will be x. If x is negative, the absolute value of x will be negative x. And given the fact that both of these guys will end up being positive, because absolute value makes everything positive, is just basically the distance from 0 to whatever that quantity value is. Nothing negative, always positive. All right. When you have a situation like this, the two cases, you need now to have two graphs, really. And in this case, there are two linear graphs that you have to deal with. One is the y equal to x. So we're taking the y equal to x just like that. And then the next one is y equals to minus x. But for each of these guys, there is a restriction. So restriction is, so x has to be greater than 0 for the first part. Okay, that means if x is positive, that's what it's asking you to do. If x is positive, then when you plug in numbers value that are positive inside the absolute value, you're going to get a positive value back. Okay, so you do the same thing. And then the next restriction for the second line, y equal to negative x, is x minus x is negative, or x less than 0. So when we graph both of these, you can see what is happening, and then we have to discuss what it means. Remember that we are graphing y equals absolute value. So this is the equation, or the function that we are graphing, y equal to absolute value of x. So let's go to Desmos and graph that, and let's see what happens. Let's go back and graph y equal to x first. Sorry, let's do that first. All right, so that's the line that we're going to get. Is basically a diagonal line. Slope is 1, and it's very simple. All right, let's do the next one, y equals to negative x. Here we go. That's the green graph. Fantastic. But here's the thing. With the absolute value function, we cannot have any values that are for y that are negative. Y can never be negative. Y values, or the range for this function, can never be negative according to the definition of the absolute value. So once we include the restrictions, and this is the beauty of the Desmos, you can include restriction. I'm using a curly bracket, and I'm going to put the restriction in. So for the first one would be x greater than 0. So I'm using the keyboard right now. All the brackets are on the keyboard. So notice what happened to the blue graph. The bottom piece right here in the third quadrant, that line is gone. There's nothing there. All right, because everything has to be above x-axis for the definition of absolute value. Next one is x is less than 0. So less than 0, and look at what happened to the green graph. Again, flips over. That means no y value for either one of these two equations, or either one of these two functions, can be negative. All right, now let's compare that. I'm going to just write up y equals absolute value of x. And the bar that I'm using is right, the key right below the backspace on my keyboard, or you can come up here, come down here with the keyboard, click on that. The second brackets that you can have, an absolute value is right here. That's the absolute value. So you can have everything in front of it if you want to use the keyboard right there. All right, so let's go back in here and punch in absolute value of x, and look at that. The purple graph, I'm a little bit colorblind. I think this is purple. Purple graph is matching exactly the blue graph and the green graph. So the V-shaped graph you see, that is the parent function for absolute value. Okay, simple as that. It's a V-shaped graph, and we don't the 0, 0 right here, the origin where the direction changes. there is no actual name for that. If this was a parabola or a quadratic function, we would have called that a vertex. Some books have seen it labeling that, but if that makes it a little bit easier for you to navigate through the transformation of that function, moving it up and down, left and right, and all that stuff, you can. It's all good. All right. So that's what that is. That's the graph of absolute value of x. And from this point on, everything that you've learned from the quadratic functions applies here. So if you look at, let's say, absolute value of x, and then add, let's say, 1 to it, guess what happens? The graph moves up. So whole graph moves up by 1 unit. Now the bottom piece from 0, 0, where the curvature or the line changes direction, goes to up to 0, 1, and every single point, actually every single coordinate goes up by 1, and so that's the y coordinate. And you can just continue with that and type in any of those transformation. Great. When you add value to x inside the absolute value, just like the quadratic, the function moves to the left by -1. There, that's -1 right there. All right, so now it's moved to the left. Okay, now if this was -1, it would have moved to the right. If we would have x -1 inside the absolute value, that would have been moving the graph. The original graph would have moved to the positive value 1. All right, and the next one will be the expansion compression. And you guessed it right, is again the same thing that happens with the parabolas, right? Because of vertical expansion, the graph kind of closes down a little bit, becomes skinnier, becomes more narrower. That's what this is happening here. So all the y values is being multiplied by 2 in comparison to the first y value. When x is 1, is right here, y was 1 for the absolute value of x, but when x is 1, then for an absolute value of 2 times absolute value of x, you'll get y value will be 2. So everything is doubled, and that's basically it. Now what happens if it's a half? You guessed it, the graph opens up, okay, and it just widens. All the y coordinates based on the original reference x coordinate, they are half now. So the y equal to 1/2 absolute value of x. I left the green graph in there so you can see the difference between when you have what happens when you have a 2 in front of it and when you have a half in front of it, just like what you're used to with the quadratic functions. Okay, and the last piece, what happens if the leading coefficient is negative? Okay, so I just chose the 1/2 x. I put a negative in front of it. Look, exactly the black graph now is basically flipped right over. Okay, and so here we go. So it's just flipped right over. Now every value is negative because you already have a negative in front. So whatever the value of a half times absolute value of x is will end up being positive, but because you have a negative in front, the final answer for y values will all be negative. So everything is negative. It's just that everything flips down. So I have created this general function for absolute value, and I created a few sliders. By the way, you just type in y equal to a, just exactly what I've done here, and then it gives you the option a, b, c as a slider. You just say yes, click on that, and it will give you all the sliders. Okay, simple as that. And then you just say yes. So for example, if I go ahead and do this, so let me close all of these. Look what's happening. It says add list slider. So when you type that in, this will show up. You just say a, I want a slider, B, I want a slider, and C, I want a slider. And based on that, notice that what happens when you use change C. Goes up and then comes down, and then we're gonna stop it. Yeah, so it comes down all the way. Okay, so and then the next piece will be what happens. So let's go back to 0 right there. Okay, B is the left and right. Here we go, and if it's negative, and it's going to be left and right. So negative value goes to the left, positive value goes to the right. Simple as that. All right, but remember, it will show up as a positive value in there. And then the last piece will be the A, right? So look at that. It just closes down. The vertical value gets stretches, and then what happens if you have a negative? flips down. The moment it is negative, it flips down. You see that? So as soon as it's negative, so remember, if a is 0, then you're just going to have y equal to c. That's just your x-axis, so nothing special about that. But the moment it's negative, the graph flips. All right.
Make sure you come back to the next video. In that video, I will be going over a few examples of graphing absolute value functions. We're going to graph from equation to graph, and we're going to go from graph to equation, and all of that has got to do with absolute value functions. All right, if you found this useful, like, comment, and subscribe, and make sure you check out the entire channel. I have tons of lessons for all the grades from grade 8 to calculus, and every topic is pretty much covered. Until next time, keep at it.